Right, in this video, I'm gonna go over an example of how you can go from the y versus x graph of a wave to a y versus t graph of a wave. Now, I do want to remind you, okay, so first I want to tell you what scenario I have thought of to use. So this is the sea, okay, so here is the sea. This over here is a wave, so I got a sea wave, or maybe I should say a pulse. It's not really that regular. And then it is me. Okay, I'm just relaxing here in the sea. I'm not moving. I'm not going anywhere. Okay, I'm too lazy to do that. I'm just staying at this specific point. And really, I'm waiting for the sea wave to come to me. Now, I have mentioned in the past a y versus x graph is really a snapshot, like a picture, a photograph when you look at a wave. And in this case, I am looking at a wave at a specific moment in time. So this is what the graph of the sea wave, the y versus x. Okay, this is the x, this is the y. This is what the y versus x graph of the sea wave looks like. It's like you take a picture, a photo of the wave. Now, here I have the y versus time graph of the wave. Now, I mentioned for the y versus x graph, like this is taken at a specific moment in time. So right now I'm looking at the wave. I took a picture of the wave and I stored it. This is the y versus x graph. In contrast, when you look at the y versus t graph, you need, since this is a function of time, what I need to specify is the x. So I need to have a specific x that I'm looking at. And in this case, I'm going to be looking at the x where I am. So this y versus t graph will be made, I will make this y versus t graph for this specific x, my location. All right, now let's see how we're going to do that. So I have, let's say, the distance between me and this part of the wave. Let's make that to be, say, 10 meters. Okay, I'm just making up numbers here. So that distance is 10 meters. Let's say that the wave is traveling towards me at 1 meter per second. Now, given these two numbers, this distance is 10 meters to the first part of the wave, and the speed of the wave is 1 meter per second. In how much time will the wave hit me? So 10 meters, 1 meter per second. If I want the wave to cover 10 meters, I need to wait for 10 seconds. Now, what will I be doing until for those 10 seconds? I'll be doing nothing really. I'm gonna continue relaxing here because nothing much is going on. I'm just relaxing in the sea. Okay, so for the first 10 seconds, I am relaxing in the sea. Relaxing in the sea means if this is the zero, from 0, let's make that to be 5 and 10. That means for the first 10 seconds, I'm relaxing in the sea. My y position is at 0. Go back here. Relaxing in the sea for me means I am at y equals 0 for the first 10 seconds until the wave hits me. Now, there will be, okay, so the wave is coming, is approaching. At t equals 10 seconds, the wave will arrive at my position. At t equals 10 seconds, I will not have y equals 0 anymore. Instead, I'm gonna have the y position of the wave because the water level is gonna be here at this point. This means at 10 seconds, I'm gonna be going up at the same height as the wave. Now, let's say that this is the length of the wave. Let's say that this is 1 meter. Okay, again, I'm making up numbers. Now, since the wave is traveling at 1 meter per second, this means that I'm gonna stay here this phenomenon from here to here is gonna last 1 second. Okay, from here to here, this is gonna be 1 second because this distance is 1 meter and the wave is traveling at 1 meter per second. So for 1 second, let's say here, oh, that's my transparency. So for 1 second, let's say here, it is somewhat difficult to write while you're looking at it through the phone. So for 1 second, I'm gonna be up there and then I'm gonna come down, because again this distance of the wave is 1 meter and the wave is traveling at 1 meter per second. So at t equals 11 seconds, I'm gonna go back down to y equals 0, and then the wave is just gonna keep going away from me, which means that I'm gonna continue relaxing from 11 seconds to the end of time. I'm gonna be relaxing at y equals 0. Okay, and this is 11. This is what the y versus time graph looks like in this case, okay, with the numbers that I gave you. Now I will make some more videos with different examples